Hi everyone, these are the Calculus 4.7 notes. This section is called Optimization. So you can find this sheet on Canvas and you can print it out using the link attached to the notes. Or if you can't print it out, you can just do it on a separate sheet of paper. So over here we've got the definition of optimization. What is optimization? So optimization simply means to find the minimum or maximum value of a function. So optimization is kind of an umbrella term. It means to minimize or to maximize, to find a minimum or to find a maximum. So what do? What are you supposed to do to find a maximum? So if you think about chapter 4, we have learned that anytime you want to find the minimum or the maximum of a function, you have to find the first derivative, set it equal to 0, get the critical numbers, and see which one is the max or min. So over here where it says what to do, we're going to find the first derivative of the function being optimized. Okay. Then we're going to set that derivative equal to 0, right? So then we're going to find the critical numbers, and then we're going to answer the question. Okay, so I have 3 examples to help you understand what we're doing. You basically know how to do this section. It's just that now they're in word problem format. Basically, we're finding a max or a min, and you've done that all of chapter 4. So in example 1, it says, calculate the smallest possible product of 2 numbers if one is exactly 9 greater than the other. So first of all, let's think of the 2 numbers. 2 numbers. We don't know what they are, so one of them could be x, and the other, it says one is 9 greater than the other. So the other one can either be x plus 9, or you can call the first one x minus 9 and the second one x. It doesn't matter, as long as they have a difference of 9. So the 2 numbers are x and x plus 9. Now, let's look at the most important words in this problem. It says smallest possible product. If you think of the words smallest possible product, smallest, if you had to choose, if smallest means minimum or maximum, I think you would choose minimum, right? Minimum product. Product is just product. So what we're doing is we're going to find a function that represents the product of these 2, and then we're going to find the minimum of that function. So our product is going to equal x times x plus 9, because product means multiply. So instead of writing product equals, I'm going to actually use function notation. I'm going to call it p of x, and I'm using p instead of f, or you can use whatever variable. But since it's a product, I'm going to use p of x for product, equals, I'm going to go ahead and distribute that x squared plus 9x. So I have got what we call the product function. Now I'm supposed to find the minimum of that function. So that means I have to find the derivative of p. So p prime is 2x plus 9. We're going to set it equal to 0. We're going to set the derivative equal to 0. And of course, we're going to solve for x, and we're going to realize, oh, x is negative 9 over 2. Now, we don't stop because we're going to go back and we're going to read the question. It says, calculate the smallest possible product. X is not the product. X is one of the numbers. Okay, so if x is one of the numbers, then the other number is going to be negative 9 halves plus 9, which is actually positive 9 halves. So one of the numbers is negative 9 over 2. The other number is positive 9 over 2. And so the product, right, calculate the smallest possible product, is when we actually plug in those 2 numbers and multiply. So we're going to multiply the 2 numbers that we got, negative 9 over 2 times positive 9 over 2. And our answer is going to be negative 81 over 4. This is our answer, negative 81 over 4. That's the smallest possible product of 2 numbers who have a difference of 9. Okay, let me go on to Question number 2. Question 2, what are the dimensions of the largest rectangle? Okay, largest rectangle means maximum, largest, so obviously it's not minimum, it's maximum. Largest rectangle means maximum area of a rectangle. So our goal is to find the derivative of the function that represents the area of a rectangle. So we're gonna have to do that. So it says, what are the dimensions of the largest rectangle that can be inscribed in the ellipse, blah, blah, blah. So this is the ellipse. First of all, quick review of ellipses. How do you graph an ellipse? You want this number to equal 1. So I'm gonna divide both sides by 16. And I'm gonna get x squared over 16 plus 4 over 16 reduces down to just over 4 equals 1. So if you remember, for an ellipse, the largest number denominator is a squared and the small one is b squared, which means a is 4 and b is 2. And because the larger number is under x and it's not under y, this ellipse is going to be long in the x direction, not in the y direction. If the 16 were under the y squared, it would be longer in the y direction. So I'm going to go out 4. 1, 2, 3, 4. 1, 2, 3, negative 4. And I'm going to go up and down 2. 1, 2, 1, negative 2. And I'm going to just kind of sketch this ellipse. Okay. And I'm going to inscribe just a random rectangle inside of this ellipse. Inscribe means all the corners have to touch the ellipse. So I'm just going to draw any old rectangle in here. And basically, I need to find, the hardest part of this problem is going to be finding the area of this rectangle formula. So area of rectangle is what we need. Because if we're going to find the maximum of that, we're going to have to find the derivative of it, right? So we need the function first. So I think we all know that the area of a rectangle is base times height. So I need expressions for this length from dot to dot and from dot to dot, okay? I think we can all agree that this is x. Any distance from the origin to the right is x. And I think we can all agree that this is y. So if you really think about this piece being x, then this is x also, which means the length of this rectangle is 2x, okay? And the height of this rectangle, y and y, right? These are equal from origin to the top to the bottom. Y and y is 2y. And so what's the area of the rectangle? It is 2x times 2y, which is 4xy. So I have this function, area equals 4xy. And so as soon as I have a formula, a function that represents what I'm talking about, I'm supposed to find the derivative, right? And set it equal to 0. The only issue is we don't want two variables. We don't want two variables for these problems, okay? We want everything in terms of one variable. So it's either going to be a of x or a of y. I'm either going to have to get rid of the x or I'm going to have to get rid of the y. And how is that going to happen? Well, I'm going to go back to the equation of the ellipse. The original, I'm going to do it over here. So the ellipse was x squared plus 4y squared equals 16. And I'm going to choose the one that's easier to solve for. For me, it's easier to solve for x, okay? So I'm going to subtract 4y squared, and then I'm going to square root it, and I'm going to get x equals the square root of 16 minus 4y squared. And I know it's supposed to be plus or minus, but because x represents a length, I'm going to choose just the positive. So this expression is going to go all the way into here. And so my formula for the area is going to say 4. Instead of x, it's going to say rad 16 minus 4y squared, and then times this y, times y. So now I have an area function, and it's all in terms of y. So I'm actually going to call it a of y. Area in terms of y equals 4y. And then it's 16 minus 4y squared to the half. And I'm choosing to write it as a fractional exponent because I know I'm going to have to find the derivative using the product rule. All right, here we go. A prime of y. The derivative of this is going to require that I use the product rule. Derivative of first times second, right? Plus derivative of second. So power rule, 1/2 goes in front. We have 16 minus 4y squared to the negative half times the derivative of the inside, which is negative 8y. And then so that's derivative of second times first, which is 4y. So all of this gives me 4, and I'm going to go ahead and revert back to rad instead of a fractional exponent. Rad 16 minus 4y squared. I've got negative, so this is going to turn minus. 8 times 4 is 32, divided by 2 is 16, right? This. I've got y squared right here, and this one is going to be over rad 16 minus 4y squared, just like that. This is the function I have to set equal to 0. Okay, so I'm going to set this function equal to 0 right there. I'm squeezing that in. I hope you can see equals 0. But I'm not going to try to solve it until I have a common denominator. Okay, so over here, I'm going to try to the common denominator between 1 and rad 16 minus 4y squared is going to be rad 16 minus 4y squared. So if I multiply this one by a rad 16 minus 4y squared, it's going to become 4 parentheses, no more rad, 16 minus 4y squared minus 16y squared, okay? Which I know I'm going to set equal to 0, but before I set equal to 0, I'm going to simplify this. This is 64 minus 16y squared minus 16y squared is 32y squared. 32y squared over rad 16 minus 4y squared equals 0. So what will make the numerator equal 0? Let's see, 64 minus 32y squared equals 0, which means subtract, divide y squared is equal to 2, which means y is equal to plus or minus rad 2, but y is a length, so just rad 2. Okay? All right. If you set this one equal to 0, rad 16 minus 4y squared equals 0. That means 16 minus 4y squared equals 0, which means y squared is equal to 4. Y would equal 2. But if you think about that, if y is 2, then the ellipse would be right here in the middle. It would not have a wideness to it, a width to it. It would just be here. So it cannot be y equals 2. It's definitely y equals rad 2. So what was the question? What are the dimensions of the blah, blah, blah? Okay, so we've got a rectangle whose height is 2y. Do you see it? So the answer, I won't write the answer here. I'll write the answer here so you can see it. Okay. The answer is height is 2y. So 2 times rad 2 is 2 rad 2. And its base, or the length on the bottom, is going to be 2x. So I actually need x. So if my y is rad 2, look over here. You can use really any of these equations to get it, but I think this one's the easiest one for finding x. If I plug in rad 2 into y, I'll get rad 16 minus 4 times, what's rad 2 squared? It's just 2. 4 times 2 is 8, which means rad 8, which is 2 rad 2. So if x is 2 rad 2, then 2 times x is 4 rad 2. And so the answer is our rectangle has dimensions 2 rad 2 by 4 rad 2. Okay, one last problem. I hope you're still paying attention. It says, a farmer wants to fence a rectangular pasture on a 3,750 square foot piece of a riverfront property. So I wanted to include the picture with this and I forgot. So let's just include it now. So let's say this is the river, okay, river. Riverfront property means your property is attached to the river. So it's a rectangular piece of land, but this part's water. And it's 3,750 square feet area, right? Square feet means area. So he wants to fence this. All right, fence, fence, fence. He also wants to separate the pasture into 4 regions. So the regions, I wanted to tell you, but I forgot. So I'm just gonna draw it for you, are gonna look like this. 4 equal regions where you're separating vertically, not horizontally. It says, what is the least amount of fence in feet? All right, let's think about that. Least amount of fence. That's not smallest area. That's length of fence. That's like kind of like perimeter, although perimeter doesn't, I can't call it perimeter because perimeter is only the outside. So I'll just call it length of fence. So this means minimum footage for fence. Okay, the length of the fence. So what is the least amount of fence he will need to purchase, assuming he doesn't fence in the land along the river? So no fence. This squiggly part, which represents the river, doesn't get a fence. However, this part will get fencing, and this part will get fencing, and so will this, and so will this, and so will this, and so will this. So this is Y, and this one's Y, and this one's Y, and this one's Y. So if I ask you for an expression for the total amount of fence, so I'll say length of fence, you would call it Y plus Y plus Y plus Y plus Y plus X. That's 5Y plus X. This is the function. I'll use L for length of fence, 5Y plus X. Now, we know that after we get the function, we're supposed to find the derivative and set it equal to 0 because we're finding a minimum, right? But we don't want 2 variables. So we have to go back and figure out what on earth we're going to do to get rid of one of the variables. Well, back to this fact where it says the area of the lot is 3750. The area of this rectangle right here is 3750. How do you find the area of a rectangle? Don't you do base times height? Isn't 3750 equal to X times Y? It sure is, okay? Because that's the fact we're going to use to solve for one of these. So pick your favorite. I don't know which one you want to solve for, but I'm going to go ahead and solve for X. X is going to equal 3750 over Y. And I'm going to take that and I'm going to substitute that right into there. And so L is going to equal 5Y plus, instead of X, I'm going to substitute that with 3750 over Y. And so the function in question is going to be L of Y. It's a function in terms of Y. 5Y plus 3750. I'm going to go ahead and write that as Y to the -1 power because I know I'm going to have to find the derivative. So here we go. That's the function. Here's L prime of Y. The derivative of 5Y is 5. The derivative of 3750y to the -1 is -3750y to the -2. This is the one I have to set equal to 0. So I'm going to go ahead and write 3750 over y squared equals 0. I'm not going to do anything until I have a common denominator of y squared. So that's going to equal 5 times y squared minus 3750 times 1 equals 0. I'm going to set the numerator equal to 0 and solve for y. So 5y squared minus 3750 equals 0. That means y squared equals 750. And so y is the square root of 750, and I'm not doing plus or minus because y is a length in the picture. And if you reduce that, the square root of 750 is actually 5 rad 30. Okay, now let me go back to the question. What is the least amount of fence he will need to purchase? Okay, so the least amount of fence means the total length of the fence, right? Where is the function that represents total length of fence? It's right here. I don't even have to bother getting x. I mean, I could totally use this function here because that's equal to L, but then I would have to spend some time getting x. So I think I'm going to use this one. And so the answer is going to be 5y. So 5 times 5 rad 30, that's the y, plus 3750 over y, which is 5 rad 30. And I took the liberty of punching this in before class to get, you know, kind of to see, because it's a real life question, I wanted a decimal to help us. And when you punch this into the calculator and you round, you get 273.9 feet of fence is what he will need to purchase. And that's the end of the notes. Thank you for paying attention. Bye.